Hello and welcome to our video journey of daily challenges. Today is day 12. Let's begin our daily challenge. Okay, question 926. Flip string to monotone increasing. A binary string is monotone increasing if it consists of some numbers of zeros, possibly none, followed by a number of ones, also possibly none. So monotone is a bunch of zeros followed by a bunch of ones. You're given a binary string s, you can flip s I to change it from 0 to 1 or from 1 to 0. Return the minimum number of flips to make s monotone increasing. Okay. Let's see, if input is 0, 0, 1, 1, 0, the output is 1 because we would only need to flip this 0 to 1. And that is also the minimum number of flips to make this string monotone. Okay, makes sense. What about example 2? 0, 1, 0, 1, 1, 0. Here we could, okay, let's see, we could make, oh yeah, so we could flip these two zeros to ones to make this a monotone string. Okay. Alternatively, we could also flip this 1 to a 0 and flip this 0 to a 1. Okay, interesting. So it seems like this question can be split, the string could be split up into almost a left portion and a right portion, and we could just iterate through, starting from the beginning, and make sure that, and keep track of how many zeros are on the right hand side and how many ones are on the left hand side. And as we traverse the characters, if the character that we're looking at is a 0, then the character that we're looking to is a 1. Okay, basically, the two variables are going to be keeping track of the zeros on the right and ones on the left. They will be updated as we traverse these characters. Let's start the implementation. I'm going to roughly draw this out first. On the right, we have to keep zeros on right. Let's initialize ones on 0 on right, ones on left, also equal to 0. And for C and S, we're going to do some operation and then return the answer, or min flips. Min flips is going to be initialized as the max length of S, and here we're going to say that if, let's see, flips is less than min flips, Okay, so you can see that even without even solving the problem, I have a rough draft of what should be happening. Obviously these aren't initialized to the right things, and flips isn't even initialized, but the way that I see this is if I keep track during the whole iteration, during the whole traversal of the string, if I keep track of zeros on the right and ones on the left, then I can say that the number of flips will actually be, the number of flips will be zeros on the right plus ones on the left. This way, we immediately know how many flips it would take to get a monotone string. At this point, we have to also initialize zeros on the right to a specific number. There could be some fancy Pythonic way of doing this with string operations, but we're just going to do it the regular way. If c is equal to 0, I'm going to say 0 to the right plus 1. Let's move this here, initialize. So now we have zeros on the right initialized as if we're looking at the first error, or as if we're before the 0th character, and ones on the left is 0 because there is nothing on the left. Okay, now that we have this initialized, let's make the mechanism to count which character is currently being processed. So if c is equal to 0, then we're going to say 0 is on the right minus equals 1. Else, the only case is that it's a 1, I'm going to add ones to the left plus 1. Submit this. Wrong answer, output 5, expected. Interesting. Run this first. Output 5, expected 1. My logic seems correct. Let's look at the initialized values just to make sure that we're initializing them to the correct place. There is 3 zeros on the right and 0 ones on the left. Let's flip these two. Let's actually do this. There's 0 ones on the left, 3 zeros on the right, 0 ones on the left, 2 zeros on the right. The mechanism is working correctly. Then when we're here, it's going to be 0 ones to the left, 1 0 on the right. At this point, there will be 1 on the left, 1 0 on the end, and finally 2 ones on the left, 0 1 0 on the right. And the output is 5. Where does it get the 5 from? Confused as to where it gets the 5 from, because flips doesn't even add up to 5 at any point of time. 3, 1, but the output is 5. If flips is smaller than min flips, then min flips is equal to flips. It's very interesting. Spelled it wrong. Say constant. Problem, I had it spelled wrong, so it wasn't picking up the right variable. Okay, sweet. So now that it's actually correct, let's see. The output is 3. However, expected is 2, and expected is 2 is correct because the first time that we're doing this, the first instance, is we can just flip these two to a 0, and that should be good enough. Why is the output 3? I don't know. Let me uncomment this print statement to see what is going on. Six, 5, 4, 3, 3, 3, 2, 1. Okay, so I know what's happening here right away. We're not considering the last character at all. So this seems like an edge case. Let's implement our own loop. Say that I is equal to 0 for I in range len s. We're going to first get the character ci, and then additionally we should be getting the same output. We should be getting the same output 3, but we actually have to go a step further. We have to go a step further and say that, let's see, let's do it this way. While s is greater or equal to len s, and since the last flip that we're doing here, I1, if I is equal to len of s, then return min flips. Yep. So what we did here is essentially, since we care about the position of our separator, it's not actually the position of the character. So the position of the separator has to iterate not over length of s, but length of s plus 1, because this is the first position, second, third, fourth, fifth, sixth. That previous failed instance, we weren't considering the failed instance here. However, now we are, and now the answer is correct. Let me see. This should be right. Okay. Sweet. Looks good. However, what doesn't look good is the amount of people that we're beating. Seems like there's faster solutions. Let's look through some of them. maybe do one that is, one that is weirdly simple, usually has some clever idea of how to go about this faster. The solution here seems to be that dp, which I don't know what that means, and number of ones, and number. So the number of ones on the right is initialized as dp is the min flips, and what he's doing here is counting the number of ones in S, counting the number of ones in S, and also choosing the minimum from dp plus 1 over the number of ones. So why would the minimum of y plus, only in the case that it's 0 do I now calculate the minimum of the solutions here, although they are better or faster, it seems to me like they're less intuitive. Even here, min flips mono, zeros and ones, this looks good. And then for a while I is less than f, if it's a 1, add to 1. If it's a 0, add to 0 and subtract 1. Yeah, I don't know how these answers are intuitive. Although they are faster, they're not easier to understand or read.